Hey Year 12, welcome to the fourth video in this MM4 series. We have looked at absolute and percentage errors. Remember, absolute error, plus or minus half of the smallest measurement. Percentage error is your absolute error divided by your measurement, expressed as a percentage. We've looked at parts of circles, things like circles, semicircles, quadrants, sectors, and annuluses. Right? If you've forgotten what those things are or how to calculate them, good time to review it. We also looked at composite areas, where we take something that is doesn't have a single formula perhaps, right, and we dissect it into a couple of rectangles, triangles, circles, and so on, and add or subtract those as necessary. Okay, so far, apart from that percentage error, lots of revision. Simpsons Rule is what we're going to learn about today, and this is something that's new. Right, so this is something that we haven't used before. Now, Simpsons Rule we use for calculating or for estimating the area of shapes that no amount of dissection is going to reduce to familiar shapes. Okay, we're going to use things like, I don't know, the area of a paddock bounded by a creek or something like that. Right, we use this area of a dam or something. They're fairly common questions. Right, something with a weird wobbly edge. We're not going to get an exact answer. We're going to get an approximation. So we use this little squiggly equal sign to show that this is an approximate answer. Okay, it's an approximate answer. So that's a bit new. You do get the formula for this on a formula sheet. Perhaps you might remember it as you go along. All right, with enough practice. Now, the way, I'm not going to explain how Simpsons Rule works. You can look that up if you want, or you can ask me in class and I'll talk to you about it, but it's really not that necessary. We need to apply this formula. Now, it has 4 terms there, or 4 variables that we need to substitute into this formula. Now, df, dm, dl. FML stands for first, middle, last. I don't care what you think. It stands for first, middle, last. Okay, here's my first one, my middle one, my last one. I want to know how tall each of these lines are. Okay, first, middle, last. And H is for how far apart each of those lines are. Now, one of the ways that these questions are frequently complicated, we'll see it as we look at some questions. One is that either F or L sometimes are 0. That can be a little confusing. Also, sometimes you're not given H explicitly, but you might be given the distance the whole way along here, in which case you would halve it to find H. Now, these 3 measurements, the F, the M, the L, they have to be equally spaced. Okay, keep all of those things in mind. Now, we're going to apply the formula, and here we go. Here's an example. I have this weird looking shape here. I want to estimate approximate area of this shape. Right, I've got well, do I have enough measurements? What I actually have here, right, I'm going to say this is DF is 10. This is DM is 30. And DL is 0. Yeah, 0. That's got a height of 0. Right, that's important. I've got to put that in my formula. And H equals, not 90, 45. If you've got room, draw those on the diagrams. It helps. Now, my area is approximately equal to, it is H over 3, 45 over 3 times, now it's the first one, 10, plus 4 times the middle one, 4 lots of 30, plus the last one, my 0. Okay, first one, 4 lots of the middle one, the last one, and that's multiplied by H divided by 3. There we go. Now, let's get in the habit of using our calculator. I'm going to apply my own order of operations. I'm going to do the middle part first, inside the brackets, and I've got a multiplication, so I'm going to go 4 times 30. Why does that have an off button? I don't know. 4 times 30, yep, plus 10. I don't need to add the 0 on, equals that. So the inside of my bracket is 130. I'm going to multiply that by 45, equals, and then divide that by 3. Yep, and I get approximately equals to 1,950 square meters. Yep, the area of that is approximately 1,950. You know how you can sort of satisfy yourself that you haven't made a big mistake? I like to look at a rectangle drawn over that. Right, I want to sort of average that out into a rectangle, and I reckon if it was about 20, if it were about 20 meters high, that would be all right. 20 by 90, right? That would be a similar area. 20 by 90 is going to be 1800, right? It's pretty close to that, right? I don't seem to have made a gross error. Now, we could, right, take an area like this and use Simpsons rule more than once. In general mathematics, mathematics general, you only ever need to use it up to twice. You don't need to use it more than twice. Okay, now what that means is I'm just going to have this one here. Okay, where I've got a 32, 31, 24. And I've got this one here. Something like that. 24, 29, and 30. Okay, that's when we do this twice. Yeah, these are the sort of figures we use for Simpsons rule. Right, I'm just going to split it up into 2 different lots. Right, now those together. Now my 105, there are 1, 2, 3, 4 strips that are equal to 105 meters. So 105 divided by 4 is, what is that thing here? You know what? It's 26 and a quarter. So H equals 26 and a quarter. So this means that I'm going to call this area 1 and area 2. Area 1 is approximately equal to 26.25 over 3 multiplied by, 32. 4 lots of the middle one, 4 lots of 31, plus the last one, 24. Right. Now you can use your calculator there and you get 1,575. 75 square meters. Area 2 is approximately equal to, again, the 26.25 divided by 3 outside of, now 24 plus 4 lots of 29 plus 30. Yep. Which is approximately equal to, you type that into your calculator, you'll get 1,487.5. That seems, seems a bit too accurate for an approximation, you know. Anyway, 1,487.5 square meters. Therefore, my area total, we just add those 2 things together. Okay, 1575 plus 1487 is approximately, I'm going to say it's approximately 3,060 square meters. 3 significant figures. I could look, that is a rational number. I could write as 3,062.5. Right? If you put all those numbers in, you get that. Look, it's an approximation. I haven't written that. It's an approximation. It shouldn't be that accurate. Okay, you can follow that working there. I think that, that rounding it off a fair bit is the most sensible thing to do in this situation. Anyway, that's Simpsons rule. So, things to watch out for in Simpsons rule is when you are given a length that's not h, right? Some multiple of h. So watch out for that. And sometimes one of your measurements is a 0 and that won't be listed because you can sort of observe the 0. Righto, that's it. I will see you in class.